Okay, let's go through these ones. Complex unfamiliar questions. This is chapter 17 and 18 in the Cambridge textbook about normal distribution and sampling. Like those two chapters are the hardest one to apply, I think. But it's easy to generally get the idea, but you need to do a lot of questions to actually be able to apply it in like a complex unfamiliar context. So lifetime of a certain brand of light bulb, when you see keyword normally distributed, you know it's a normal distribution. What are the two parameters for normal distribution? Mean, sigma, right? Let's say we have both of them. Mean of 400, okay, good. Standard deviation 50, okay, good. We have the mean and standard deviation. Let's write that down. Mean and standard deviation, okay. Question A, find the probability that a randomly chosen light bulb will last more than 375 hours. Okay, so this one means that the lifetime, right? This is the lifetime distribution, has a mean of 400 and standard deviation of 50. Always make it a habit to draw this one and then go 1, 2, 3. If you have mean and standard deviation, you always just draw out this thing, right? It will be easier to visualize what it means. Okay, so that's 350, 300, and 250. Okay, so the lifespan, most of the lifespan will be 99.7%. Remember the 99.7 rule. 99.7% of the lifespan will be between 250 and 550 hours. So they ask, what's the probability? So question A is, what's the probability that the lifespan, let's call that X, lasts more than 375 hours. Well, 375 is roughly here, right? And it's just, what is this area? They're just asking what is the area from 375 onwards.
Is this one tag active?
Tag active, yes. It will be tag active. Okay, and this one is just norm. Okay, what's the function? What's the function?
Function?
Yeah, in the calculator.
So is it gonna be distribution normal?
Yeah.
It's gonna be NCD.
NCD, correct. The function is NCD. What are the parameters?
So the lower is 375. And upper is like the infinity.
Infinity, yeah. You can just use a really big number like 3999.
And 50 hours for the mean is 400, and the what's that called? The mean one is 50 hours.
Yep.
So
sigma is 50.
Sigma 0.691.
One sec. Let me just whip the 0.6915. 6915. Okay, we want two more decimal places.
It's actually 691462.
62. Okay. Remember, you always write more decimal place and then you write the 5 decimal place version, because later on when we need to use this, we have to use a more decimal place version. Okay, so question A is easy. Question B. The light bulbs are sold in boxes of 10. Find the probability that at least 9 will last more than 375 hours. How do we do this one? What do you think is the main idea behind this one?
It's the binomial one.
Good, binomial.
In normal distribution.
Yep. Okay, and how do we find this?
So we got, so usually I don't know if you do it, but my class usually does like, we write like binomial, and then we did like something like that.
A tilde, yeah, binomial, yeah.
And we got NP.
Yes. Yeah.
So in this case, the N is gonna be 10. And the P is like 1 over 10. Or the P is actually 0.6915.
Yes, 0.691462.
Yeah.
Yeah, that's right. This is a binomial distribution where the probability of success, because at least 9 of the bulbs in a randomly selected box, basically each bulb will have a chance of lasting more than 375 hours to be that number there, and then there are 10 of those. Yeah. So yes, it is a binomial where each bulb can last more than 375 or not last more than 375. Right? Yeah. So yeah, it is correct. And what's the function to do this?
So this is going to be probability of bigger than of at least 9. So it's gonna be 1 take away the probability of 9 and the probability of 10.
Yes, you can do that, or you can just write at least 9 here and then using
Just chuck it in the
yeah
calculator.
yeah. Just need to write use what function you use and what are the parameters.
The BCD.
Yeah, BCD.
So lower is 9. Six 9.462. So I got the lower is 9. Upper is 10. Num child is 10.
Yep. Yeah, that's right. That
And
should be the right answer.
0.136472.
0. What was it? 13.
64.
Yeah, the textbook answer is different. It's 1254.
1, 2, 5, 4. Let me round it into.
Yeah, try to use the try using
1 5 thing. I'll try to use the 1 5 thing.
Yeah. Normally they shouldn't be using the lower.
Oh, it's still 1365.
Yeah, that's strange. Okay, let's see. Yeah, 1365, right?
Yep.
Strange. 0.1365. Yeah, definitely. I think the textbook is doing something a bit strange here. They got a little bit lower. Let me see. Did they start with? Yeah, that's strange. Okay, not sure. Most likely the textbook answer is wrong. That's my only bet. I've seen so many wrong answers, confirmed wrong answers already. So yeah, assume the textbook is wrong for this one. Yeah. I think it's fair. You can double check with your teacher if you want. All right, moving on. So that one's not too bad. Right, it's only complex unfamiliar because it's written into like a context, but that's actually not a bad one at all. Still easy to do.
Oh, actually, I just want to tell you my weakness. I found really recently I did a lot of math. Not a lot, but I found out that my weakness is drawing the thing, like the one in cosine, and they tell you what to draw. Like they telling you oh, the bearing is this, placing at this.
Ah, okay. Bearings.
Yeah, pretty much like the language.
Yeah, the language, right?
Yeah.
Okay. Okay, can go through that. I'll pause this one here. Let me find a good bearings question. Let's find a complex familiar one out here, like this one. So I think this is 19D. All right. A yacht starts from a marina and sails in a straight line on a bearing of 245 for 5 kilometers to a nearby island. So when you see a bearing question, right? So look at the keyword here. So bearing, yes. Now, of 245 for 5 kilometers. So bearing of 245, and where they start from? Starts from a marina, right? The keywords you're looking for is normally from where, because bearing you always need to draw the north line from some point, right? We need to know where that point is. Once you've got the north line from that point, you can draw the bearing in, and it's always clockwise. Okay, so in this case, a yacht. Let's read that again. A yacht starts from a marina. So it starts from a marina. Say let's draw the marina as M. Sails in a straight line on a bearing 245. So 245 is from the marina, right? Does it make sense? Yeah, you need to be able to recognize these ones. So north line from marina, and then the bearing is 245. So you gotta quickly calculate. This one here is 270. So 245 is between 270 and 180, right? So it'll be roughly around here. The more accurate you can draw the angles, the better. So bring a protractor. I know it sounds silly, but it's like, why bring projector? That's like yin yang stuff. But if you have a projector, sometimes you can draw these bearings in the exam very accurately. Okay, and if you draw it accurately, it will be a lot easier to find out like the sides and stuff. So let's say from the north line there, check the projector in and then find out. Okay, let's say from the 180, I need an extra. Was it 245? Bearing of 245. You have an extra 45 degrees. Just like around here. Okay, so that bearing there is roughly 245 degrees. So we're gonna write the angle in here. Right, 245 degrees. Yeah, and you see, you already did some calculations there. What was the calculation? Well, let's draw that line there, and we know that this angle is what? Oh wait, 245. Oh, sorry, that should be 65 degrees. No, then that one is wrong. 65 degrees is roughly around here. There. Okay. My bad. That is 245 degrees. Alright? And then we know that this angle here is 65 degrees. Yep. Never hurts to draw a little bit more. Again, when it gets a little bit too complicated, you might need to redraw certain parts of it, but that's okay. Right? So this one will help you visualize a few things already. So now it sails in that straight line for 5 kilometers to a nearby island. Alright, let's use this. Let's look at the other values first. So is there any other kilometer in here? No, this is the only kilometer. Yeah. So it doesn't matter how we represent that. So let's just say this is 5 kilometers. Alright, so I'll mark it in here. That one from here to here is 5k. Alright, to a nearby island. So let's call that point I for now. How far south has the yacht sailed? Okay, so that's north and this is south. Oh, we already just found out the answer, right? Other way to do it. If you draw that triangle there, it will make a triangle that will be able to calculate how far south, right? So let's redraw that triangle. So for question A, let's redraw the triangle that we've got so far. Oh, and note that I draw this on the side here, but in the exam, you should draw in the middle of the page. If you can, okay? Put it this way, if you, let me think, to save time, see if you have enough space. So in the exam, do you just do it on like a lined paper, like just an empty line paper, or do you do it in like a given space in the question?
We do it in a space.
In the space in the question. But if you have need more space, you can just ask for more paper, right?
Yeah.
Okay. But try to draw it in the middle if you can.
In the middle.
Like closer to the middle. So for example, if you have like a pages like that, yeah. And normally these kind of question, if it's long, it will be on top, right? So try to draw it. So leave some gaps here and leave some gaps here, leave some gaps here. Try to draw whatever the bearing thing in the middle here, and then you start working out down here. Yeah. Right? Because just in case for bearing question, you might need to extend that on this side or extend it here or extend it there. If you draw in the middle, you don't have to redraw it. And if you run out of space, you can always just get a new paper and continue the question in the new page. That's no problem.
So can we draw it in like pencil or something?
Yeah, you can draw it in pencil. Yeah, you should draw it in pencil.
Do we still get a mark?
Yeah, I think of course. Because they will not mark you for the drawing. They will use the drawing to help understand your working, but they mark you on what you actually write. They will mark you on what you write, not on the drawing.
Yep.
Yeah, unless they ask you to draw, like sketch something, which is a different case. Then they will mark you on the drawing. I'm pretty sure you can draw in pencil. Yep. Yeah, should be okay. And nobody would force you to draw in pen and like, oh, you have to rub things out now. Okay, anyway, so let's redraw the main triangle like that corresponds to this scenario here. This is like the south direction. Okay, let's call that S. This is M, this is I. We already calculated this one is 65 degrees, easy, 5 kilometers. Okay, and they asked you to find MS. Alright, make sense? But I wouldn't normally call that one S, I would call that one point A or something. Right, like a random point. Because the south is the general south direction, there could be multiple south directions. Right? Because if you have something over here and that's a north, then that will be south of that. Right? So that's why I don't normally use north and south as a point. So I'll just use A there. So I will just write cos of 65 degrees is X. I'll just write X is X over 5. Okay, so x would be 5 cos 65 degrees. So that would be 2.11309. Yep. So therefore, it has traveled south by a value of 2.1131 kilometers south. But does it make sense, Peter? Like the how far south?
Yeah.
Yeah, it's just how far south from the main point, right? And then how far west is, well, how far west is just the same thing, but I call that one, let's say, the value A here, for example. All right. So then how far west is essentially just whatever that value of A is. So then you would get sine of 65 degrees is opposite over hypotenuse. So A would be 5 sine 65 degrees, which is 4.53154. Okay, so then therefore it has traveled 4.5315 west. Okay, make sense? Next, what is the bearing of the marina from the island? All right, let's see. Now is this the kind of question, is the question C the one that you're a bit confused about? Or do you think it's okay?
C?
Yeah.
Bearing of the marina from the island. Can I see the thing? The marina. Oh, the bearing is... Wait, what? Is it the bearing is 245?
No. Alright, with you first hint.
Oh,
C.
from the island.
Yep.
Oh.
So what's the first thing that we have to do?
We need to... We're gonna draw a triangle. So we're gonna find...
We're not drawing the triangle first.
IMA.
No. I see. The keyword, again, what I said earlier, right? The from the island.
Yeah. So, yeah.
This one, because of the keyword from the island, you have to draw the north line from the island.
Yeah.
Does that make sense? Right? Because when you calculate bearing, it has to be from some point, and you have to draw the north line from that point. This is the most important thing. You look at the from keyword, you draw the north line from whatever you're supposed to be doing, right? So from the island means you draw the north line from the island. And then when you calculate the bearing, it will be this angle here. Does it make sense?
Yeah.
Yeah, because it has to go from a north line, right? And the north line is from a certain point, and the point will change. I think that's what you're confused about. Because they will ask you for the bearing from different points, and when it's from a point, you have to draw the north line and then consider from the north line. So look from the north line, right? Look from the north line, and then look until you look at the direct angle, like a straight away angle to the other point here. All right, so this actually is the angle that they're asking for question C. All right, does it make sense?
Yeah.
Yeah. Okay, so that's why for question C, you're calculating this angle here. And again, it's getting a little bit complicated, so let's redraw it. All right, so we'll have point M here, it draw a little bit here, that's point I. Now we want the north line from point I, and we already calculated a few things. Right, we calculated that this angle was 65 degrees. Right, I don't want to draw the north line from M because I don't want to confuse myself. Okay, so this is the main diagram for question C, and this is going to be, we've got what angle so far? X, we have X already, so let's call that theta. Okay, all right, so the bearing of the marina from the island is represented by that angle theta there. How do we calculate that angle?
Oh, I think we're gonna find IMA.
IMA, yes, do we know that?
No. We only know like 245. Oh, wait, what? Yeah, we know.
Yeah.
So we're gonna do what, 245, take away 180?
Yeah.
That's it.
Yeah. Because Z rule, right?
Yeah.
Yes. So therefore, theta is 65 degrees, right? Therefore, the bearing, you're gonna write the statement, bearing of marina from the island is 65 degrees. Yep. Wrong. There's something wrong about the conclusion.
The bearing.
Yeah, what about it?
Bearing of from the island.
The value is not wrong,
T.
but you need to write something else. Bearing is always
Bearings.
3 digits.
Oh, what?
The bearing is always 3 digits. If it's 65 degrees, it's 065. It's always in 3 digits. Because what's the maximum bearing?
180.
No.
Oh, 360.
Yes, 360 or 0. Well, technically, 359.9999, right? But because 360 is just 0 degree. But it's just north side. But the maximum is about 360, which is 3 digits. So that's why, to not confuse with other angles, the bearing is always 3 digits. If you have a bearing, all right, so I'll put a note here. If you have a bearing of like a very small one, let's say this is like 9 degrees, then the bearing, right, would be 009 degrees.
There's something about like N, like sometimes I see in the question, they're saying like north, 9 degrees west. Like, do we still need to put in 3 digits?
North 9 degrees west. I haven't seen that before. Because bearings normally this form here. I think the other form is, I don't think it's part of methods though. That's weird.
I got a lot of questions in class. It's about that one.
About that one.
Yeah.
Hang on. You're saying north 9 degrees west like that?
Yeah. So what does that mean? Is like, oh, it's from the north going to the west.
And 9
to
degrees.
9 degrees.
Are they allowed to teach you this? This is used because sometimes like 300 something is too much effort, and just want to see whether northwest or northeast, right?
Schools are gonna use it.
Hey?
I'm pretty sure most schools are gonna use it.
Yeah. Okay. You can use it, but the original bearing is always north side and counterclockwise 3 digits.
The T is true bearing. Is that right?
True bearing, yeah. So what I'm telling you is a true bearing. Right, well, this is like a relative bearing, not the true bearing. So this relative bearing will be equivalent to the true bearing of 351 degrees.
Yep.
Yeah, so I think if your question is give this format, you can use it to draw the diagrams and calculate the angles and stuff, but just leave the answers in true bearings. Yeah, unless they specifically ask for like a relative bearing, which I don't think they will. Yeah, because most method students, they don't learn that bearing, they only learn the true bearing.
Yep.
Okay. So that's the bearing of the marina from the island. And then now question D. The yacht now sails from the island. So again, the keywords in bearings, from. Okay, you always look for the keyword from, because from is normally where you draw the north line and stuff like that. From the island on the bearing 310. Aha! See what I said? From the island, bearing 310. Again, island, we already got the north line, bearing 310. Roughly where is it? It will be 360 minus 50. So put your your protractor in, right? 50 degrees and get roughly where that is. So that's around there. So 310 is about this one here, right? And we just calculated 310 is roughly 50 degrees from the north line. So I'll draw that as 50 degrees instead. Makes my life a bit easier. Okay, see, it's getting a little bit complicated. That's why you want to draw this in the middle. Okay, and if you can use different colored pens and pencils, if you're sure about certain things, you can use like a pen to draw like M and I. Like if you're drawing new lines, like for example, see this section there, that's somewhat new, right? You're not sure whether that's the right one, then you would draw in a pencil. Just in case it's wrong, you have to rub it out and mark the values in pencils. But the main lines, so for example, to me, the main lines would be like, the main lines would be the point M, and you need the bearing from M already, right? And then you draw all the way to point I, and you need the bearing from the north bearing from I. So I'll draw these ones in like pen, like a different colored pen, blue pen. Okay, not red, I don't think you should use red, but yeah, so use blue pen for these ones. And then you can start marking the other stuff in pencil, like, oh yeah, that angle is how much, and then draw the triangle here, and then that angle is how much, that angle is how much, that one is how much, right? And now when you calculate another line, you draw that in red, in pen again. Okay, so to distinguish your calculation, which is pencil, versus what the question is giving you, which is normally not changed in pen. Yeah. Of course, if you misinterpreted the question, that's GG, can't help you there. Okay? If you misinterpreted the question, you have to cross out the entire shape and redraw that. But that just means you have to redo it in a separate sheet of paper. Okay, hopefully that doesn't happen, but that's why if it's from the question, I'll draw it in pen. Okay, so now let's see. So bearing of 310, which is 50 degrees from 360, stops at the headland. Let's call that H. The marina is on a bearing of 115 from the headland. 115. If you can put like a protractor in here and see, see if the protractor will give you like draw the north line from the headland, right, and find an angle that's going to be 115. So because when you draw the travel path this way, right, it could go on a little bit more before it reaches a point where it will be 115. You see how it's extending to the left, and why I told you guys to draw it in the middle? Yeah. You don't know where it will go, okay? And I'm not following my own advice because I need to show the explanation over here. But if I were you, I would draw this thing in the middle from the get-go. However, for me, I can cheat a little bit. I drew it here because I can cheat a little bit. Wait. Here, I can shift that. Okay, then I'm okay. So that's why I didn't bother drawing it in the middle, because I can shift it, but you guys can't shift things like that on pen and paper. Okay, so I will extend this one a little bit and find out at which point the angle will be 115. Because remember the bearing, let's say at that point there, you have to draw the north line again, right? Because bearing, the marina is on the bearing 115 from the headland, okay? Again, from the headland, H. Wherever the H is, right, the bearing will be from there, all right? And that's why we need to make sure that you can test it so that the angle, you would put like 115 and get the headland where the bearing is 115. So that is roughly 115, right? I'm just going to use a rough value here. Or I can actually use an exact value, calculate 115, which is like around, okay, it's around here. All right, so this point there will be 115 degrees to the marina. Okay, so bearing 115.
Wait, what about 310?
310, I already accounted for that here.
Oh, right.
Right, 310 true bearing, so 50 degree northwest.
All right, yep.
Yeah, so you have to quickly calculate these things. So yeah, I don't want to write the 310 because it's too long. It's like a really big angle here. Yep. Right, so I'll write the other one, the relative one, because most likely we need that one anyway. Okay, so what else? Find the distance to the headland from the island. So HI, right? AB, let's call that the distance D. Okay, so we're trying to find this distance D here. Again, too complicated, can't see anything. It's best for me to redraw this diagram. Okay, so what would I want to redraw? First, if we want to find HI, I will need this triangle, HIM. Yeah. Right? Okay, so I'll draw this main one first, H, I, and M. So right now it might be really hard to see. The moment you see it's too complicated, you get to redraw it. So I know that M is here, and then I is roughly here, and H is roughly there. So once you've got the relative position, the reason why I asked you guys to use protractor is to get the relative position. Because if the headland is here, it's very different from when the headland is here. Right? This is bearing is not 115. Okay, so that's why I want you guys to use protractor to get a general idea of where it should be. All right, so this one then is better because the angle is an obtuse angle, 115. All right, so yeah, so that's why you should use the protractor if you can, just to get a better location for the points. But once you've got it, you can just put a rough estimate of the location is fine. So H, I, and M, and then we've got a few angles already. North line, north line, north lines. What do we need in order to calculate the 115 degrees? What do we need in order to calculate the stuff in this triangle? We know that the I from M is 5 kilometers. Yep, MI is 5 kilometers. And we need to find the distance D here. What do you think we need to find?
We need to find. We can find the angle first.
Yeah, we can find the angle. What angle?
HIM.
HIM?
Yeah.
Yep, correct. HIM. How would we find that angle?
So can you scroll up? We got some details above. So we got 65 degrees for the angle I on the right.
Yep.
And we got the 50 degrees.
Yes, that's right. So we already calculated earlier. That's why they asked you for the bearing of the marina from the island, and then you got 50 degrees here, the relative bearing. So HIM is 115.
Yeah, 115.
Yeah. Okay. What else can we find?
Can you go up? 5. Where we going?
Like before looking at this, right? What do you think we need to find in order to calculate D? An angle or a side?
It should be an angle.
Should be an angle.
Yeah.
Right? Okay. All right. Okay. Should be an angle. What angle are you looking at?
IHM.
IHM. So you're looking at this one here.
Yeah.
Okay. It could potentially work. There's an easier one in my opinion.
Easier.
No, that one could work as well. You can find HIM. Yeah, that's fine.
Do we have any other information?
This is enough.
This is enough.
This is enough. You don't need more. Just think about. Okay, remember in bearing questions, you always think about parallel lines, right? What are the parallel lines? All the north lines are parallel.
Okay. I think I know. So it was gonna be one. So So the angle H is gonna be 15 degrees.
15 degrees?
Yeah.
Yes, that's right. 15 degrees. Yeah. How did you get that?
Because it's the parallel thing, and it go like that. So it's the sum of those two angles is gonna be 180. So I take 180, take away 50 degrees.
Yes, that's right. So basically, when you see north lines, it always helps to extend the north line to see the parallel angles.
Which one did you mention before?
This one. You probably need to find both. So I'll start with this one first, and I'll show you why. So this angle, right? You're saying this angle is the same. So basically, the Z rule is for this thing here, right? Which means the other angle would be 50 degrees. And so the angle that we're trying to find is 180 minus 50 degree, which is 130, and then minus 115. So that angle is that's 15 degrees. Okay, but you have to write it. So you have to write. So for question D, you have to show angle MHI is equals to 180 degrees minus 50 degrees minus 115 degrees. All right, show some working. So that'll be 15 degrees. Okay, and then angle HIM is equal to 50 degrees plus 65 degrees, which is 115 degrees. All right, we've got two angles here. Okay, how do we find the distance D?
It could be sine rules, or we can use cos rules.
We can use the cos rule, but the cos rule needs 3 sides.
Yeah.
Yeah, we only have 2 sides.
Sine rules.
Sine rules. Okay, so if you were to use the sine rule, what is it gonna look like?
Well, we're gonna need to find HMI.
Correct.
For,
You also need to find HMI.
so it's gonna be 50 degrees for that.
Yes.
Yeah.
Yes, 50 degrees. Okay. So angle HMI. So once you found MHI, find HIM is not too bad. It's just 180 minus the other 2 angles, right? Minus 15 degrees, minus 115 degrees, which is 50 degrees. Okay, so now that we've got this one 50 degrees, easy. All right, sine rule. Again, sine rule, actually, you want to use the version where the item that you're finding is on top. So you go d over sine 15 degrees. Yeah? Equal to 5 over sine of 15. Oh, sorry, it should be 50. And this one is sine 15 degrees. Okay? And then just multiply that one over here. So d would be 5 sine 50 over sine 15 degrees. So yeah, punch that in and you should get your answer. So that would be 14.7988. And so the answer will be 14.80 kilometers.
Yeah.
Okay? So yeah, this question D is the complex familiar part where you need to do quite a lot with it. So you see this triangle is easier to solve than when you try to work with that top one there. Alright, so redrawing the triangle is very, very important. I would use the main diagram just to establish like where the points are, but when it's too complicated, you want to redraw. Okay, and just remember to mimic the relative location of the points very carefully, because if you mess up the points, all the calculations will be different, and sometimes you may not even be able to calculate it. Okay, all right. Just keep in mind that any angle more than 90 degrees must be an obtuse angle. So watch out for those ones. Yeah, that's the tricky part about bearings. All right, does it make more sense?
Yeah.
Yeah, go back, do more practice. Let me know if you have any questions, if anything. Okay. Now let's go back to 19C, more probability questions. I think we're up to question 12. Let's see. The weight of cereal boxes underweight if it's less than 500. Find the proportion of boxes that will be underweight if mu is 505. Find the value of mu required to ensure that only 1% of boxes are underweight. Okay, this is the... Alright. Yeah, this one is definitely complex and familiar. Okay. The weight of cereal in boxes packed by a machine is normally distributed. Alright, keyword normally distributed, mean unknown. Okay, standard deviation 5. So we only know the standard deviation, which is 5. And then question A is a box is underweight if it's less than 500 grams. So we don't know what the mean is, but less than 500 grams will be underweight. Right? Is underweight. Find the proportion if mean is 505. Okay, let's say mean here is 505, standard deviation is 5, which means this will be the first tick. 500 grams will be the first tick. 1, 2, 3. So 500 is here. So even based on this question A1, I can already see that it's roughly 68, 30 to 16%, I think. 32. Yeah, roughly will be 16% or 0.16. Let's see. So calculator. Proportion of boxes will be underweight if mean is 505. So this is just the NCD, and then lower is negative 9999, and then upper, right, is 500. Mean is 505, and then standard deviation is 5. Okay, so punch that in, you get the proportion of boxes. It has nothing to do with question A2, so I'll just leave it as it is. Now question A2. Find the value of mean. Now we need to find the mean so that only 1% of boxes are underweight.
Why is the upper is 500?
Because you are looking at the proportion of boxes that will be underweight. Underweight means the weight is less than 500.
But I'm saying like if the mean is 505.
Yeah. Yeah. So you're finding the area from here to 500 only.
Okay.
The mean is only the parameter.
Yep.
Now find question A2. Find the value of mean required to ensure only 1% are underweight. So now they want, okay, so remember the standard deviation is 5 grams, right? We need to find a certain mean value, so only 1% is underweight. So this one, let's visualize this. 1% is underweight. That's a really small amount. So underweight again, that's 500, right? And we need to set a certain mean, okay, where the probability to the left of that is to the left of 500 is 0.01. Right, 1% underweight, and we need to find the mean.
Yeah.
Do you guys know how to do this in your calculator?
Yep.
Okay, all right. What's the function? Okay, what's the main idea here? What do you need to do?
Invent n inverse normal.
Not inverse normal. Inverse normal you will need. You're not. Not inverse normal in this case. Oh wait. No, hang on. Let's see. No, this one you can do this without a calculator. There's an easier way to do this one without calculator. Okay. Then I need to show you guys. When you have any unknown, like mean or standard deviation for the normal distribution, right? Yeah. Anytime you have an unknown, you can always map it to the Z distribution.
Yep.
Yeah? Okay. And then the Z value of 500 is, yes, you're right, is inverse normal of the Z distribution. Was that what you're trying to do?
I was trying to jump that in.
No, you need the Z distribution, where it's the mean and the standard deviation.
Wait, do we need to remember like the equation for Z values?
What do you mean by which one?
That into.
Yes, you do.
Do we have it in the sheet?
In
the exam.
The exam sheet, I don't think so. That's a. No, you don't have it. You need to know it by heart. It's a standardization formula. So Z is x minus mean over sigma. That one, you have to memorize it. Okay? So the standardization formula is Z equals to x minus mean over sigma. And you can find the Z value of 500, right? This Z value is inverse normal, and then it will be the left tail, area 0.01, and then because it's the Z distribution, mean is 0, standard deviation is 1. So if you inverse normal that to get the Z value, right? So this one would make you Z value equals to normal, inverse normal, tail is left, 0.01, oh sorry, yep, and then standard deviation 1, mean is 0, okay. So that'll be negative 2.32635. So this Z value is the one that goes into the Z value here. Okay, so now we've got negative 2.32635 equals to the X value. What is the Z value correspond to? It corresponds to 500. Right, and then the mean is unknown, and then what's the standard deviation? Well, it's 5. Alright, does it make sense? Then you rearrange and find the mean. That's it. Yeah, not bad?
Yeah.
Yeah, so times that over, so mean would be 5 times negative 2.32635, and it will be 500 minus that. Okay? So let's see what the answer would be. Okay, so that would be 511.63. Okay, so 511.63. Let me double check. The answer should be, yeah, 511.63 is the mean. So this value is the mean that has to be set so that the area to the left of 500 is only 1%. Okay? Yeah. So what's the implication of this one? 511.63. What's the implication of this? Well, when you think about it, this is, okay, taking a step back, it's not about math anymore, but how this math is applied to real world. If you know the standard deviation, and you can test it by just taking a sample out and get a standard deviation of the sample, and then do some stuff with it. Then you get the main standard deviation of the population. Then you can calculate, okay, what you need to set your machine to. Because if you set your machine to only 505, because remember, like it's specified to be 500 grams, right? But you have to set the weight to be a little bit higher, otherwise there will be too many underweight bags in the production, and you're gonna get into trouble with the Australian Commission of like consumer protection, right? So that's why the factory will have to set it higher than 511.63, right? So they actually have to. So if you see a Pringles that said like 500 grams, they actually the mean weight of the machines has to be a little bit higher, like 511 grams, in order for only 1% to be underweight, assuming the standard deviation is 5 grams. Yeah. So that's how these math will affect like a normal, like a large corporation, the large manufacturing plant, and how they control the settings and stuff like that. Right. So that's how when you get bags of chips, sometimes you get something that's a lot heavier, and then something that's a lot lower. But you almost rarely get something that is under the weight specified by the manufacturer. Okay, interesting. Well, that's how normal distribution is applied. Last one, question B. As a check on the setting of the machine, a random sample of 5 boxes is chosen, and the setting change if more than one of them is underweight. Find the probability that the setting of the machine is changed if mean is 505. All right. How do we do question B? Peter, any idea? It's binomial again. What are the parameters?
So the numbers 5. And where is it?
Assuming the answer.
The P is 1 on 5.
Not 1 on 5?
4 on 5? Oh wait, no, the probability is it no.
Is the probability of one of them being underweight, which is the same as the answer from question A1.
So 1%.
Actually, no, it's 1%. I didn't calculate this one, but this one's supposed to be 0. So I'm gonna use their answer here, 1587. Right, this is the answer for question A1.
Yeah.
So this one would be 0.1587.
Yeah.
Okay, so what's the probability that the setting of machine would change?
Setting. So probability more than, is it more than 1? So it's going to be 2, 3, 4, 5?
Yep, 2, 3, 4, 5. So you write more than 1.
More than 1.
Right, okay, and then it will be the binomial BCD.
Yep.
Right, what are the parameters?
Lower is 1, upper is 5.
That's wrong.
What?
More than 1.
Lower is 2.
Yes, be careful.
Mean is 505.
P is 0.187, and then the number is 5.
5.
Yeah, if you punch that in, you get the probability, which is around 0.1809.
Can I see A2 again? So you convert it into this Z values, right?
You find the Z value corresponding to that and use the idea of standardization. So whenever you have unknown mean or unknown standard deviation, normally you need to think about the standard normal distribution to work that through.
Unknown means and unknown standard deviation.
Unknown mean or unknown standard deviation. Because the formula here, normally they would give, if you don't have the mean, normally you can get the X value and they give you the area, so you can get the Z value.
They have that formula in the sheet, right?
This one?
Yeah.
No.
No? X take away
Mean over sigma, yeah, over standard deviation. Yeah, if you look at the chapter 18 sheets, I think one of them had the one where you do this formula like a few times for the table of the math score. Remember, math, biology, and French, and then you compare between Mary, something. Yeah, it's this formula there. Right? It's just a standardization formula to convert from the X value, which is that one, to the Z value, the corresponding Z value in the Z distribution.
Yep.
Okay? Yeah, so that's the one.
Is it N or is it U?
Mu.
Mu.
Yeah, this is This is mu.
Alright.
Yeah, so the mean should be set at 511.63. Okay, all right, so that's question 12. Wow, these ones. This is a tricky one. All right, I'll see if I can get you guys through this one here. It's getting harder and harder, these complex unfamiliar questions. If we're running out of time, because the second half I want to go through the main concepts a little bit more. Actually, maybe let me think about it. Maybe I'll focus on solving more questions because Peter, you technically still have a little bit more over a week. So from now till maybe halfway next week, you can still try to redo these questions here. But then 1 week before the exam, just go back to revision mode, right? Do simple familiar, basically everything in that sheet there. Right? I might just cover a few key things later. I'll see how much you guys know. And then normally the lesson right before anyone's exam, I'll just go through the main concepts only. Yeah. Going through whatever questions you guys want to ask me.
Yep.
All right. But for now, let's go through all the hard ones first. Well, there's still time for you guys to practice. All right. Question 13. A factory has 2 machines that produce widgets. The time taken X seconds to produce a machine using a widget using machine A is normally distributed, mean of 10. So machine A is normally distributed, mean 10, standard deviation 2. So using the X seconds. Okay, so for machine A, it is a normal distribution. It's roughly normally distributed with mean 10 and standard deviation 2. Okay, and then the time taken Y for machine B has a PDF. So Y is a PDF. So Y is a PDF. Fy is K that, and then 8 less than Y less than 12, and 0 otherwise. Okay, find the value of K. Okay, so looking at this one, question A, find the value of K is pretty simple. Just antiderive it. Okay, so you antiderive Fy from start to n dy and make that equals to 1 and then solve for K. Okay. Right, assuming you guys can do all of this, the answer for K is that question 14? 13. 1/8. All right. So now that we've got this one, we can replace the K value in the Y distribution. Fy is equals to, that will be 1/8 of Y minus 8 from 8 to 12. And then 0 otherwise. Okay. A2, show that, let me just write this one as A1. A2, show that machine A has a greater probability of producing a widget that is less than 11 seconds than machine B. What are we doing here, Peter? What do we need to calculate here for question A2?
No idea.
No idea?
Yeah.
Producing, so this is the time, note that the time taken, right? X and Y is the time taken to produce something, right? And then they ask probability of producing it less than 11 seconds. There are 2 distributions, the machine A, so this is machine A and Y is machine B, right? Machine A is normal.
Can I ask you something?
Yeah.
Can you do question A1 again? I still don't understand.
Oh, okay. All right. So A1 is relying on, okay, so note that there are 2 distributions, right?
Yep.
B is a PDF, and when you have a parameter in the PDF, in order to solve for it, you need to use the idea that the total area is equals to 1. So you antiderive from the left hand side to the right hand side of the function, it has to be equals to 1, and then you solve for K. Right? So it's basically antiderive of from 8 to 12 of K times Y minus 8 dy, and this one must be equals to 1. Maybe I'll go through this one here. So to do this antiderivative, K is a constant, I'll take it out, right? And then I antiderive what's inside it, which is y squared over 2 minus 8y from 8 to 12, and then that equals 1. Yeah? So to solve this, you substitute the values in, but the trick is when you sub the values like 12 and 8, right? The easiest way to work it out is to factorize it first. So I'll write it as, I'll take out y here, and then inside it's just y over 2 minus 8 before I actually sub the values in.
Alright, yeah.
Okay? Then when I sub it in, you see that the math is a lot easier. So that'll be times by 12, and then that'll be 6 minus 8. Right, once you sub 12 into y, it's 6 minus 8, which is negative 2. And then minus, you substitute 8, that will be 8. And then that will be 8 over 2, 4 minus 8 is negative 4. Yep. Okay, the numbers are a lot easier to work with. And now you can take out common factors 1 again, or you can just, I guess you can just times it, it's not too bad. So it'll be negative 24, and then plus 32 equals 1. So that'll be k times 8 equals 1. So k is 1 over 8. Yeah?
Yeah.
So it's just using the main idea that the total area is equal to 1. Okay, I'll go through some of, I think the main concepts I would actually go through later, if we have some time later, ideally. All right. A2. Show that machine A has a greater probability. All right, a greater probability. So you're trying to calculate probability something x something and probability of y something. Does it make sense so far? All right, and show that it has a greater probability of producing a widget in less than 11 seconds. So remember, like less than 11 seconds and a and x is just the time taken. So just probability x less than 11 and probability y less than 11. And show that the left hand side is greater than the right hand side. Right. Does it make sense so far?
Yeah.
Yeah. Now do you think you can get this in the exam? Maybe you should go back and redo these questions.
Yeah. Can you do it?
Huh?
Can you do it?
Of course, I'm going through it now. So probability of x less than 11 and probability. So basically we're trying to calculate two things, right? PR x less than 11 and then PR of y less than 11. This is only hard because they throw two distribution. This one is a normal distribution and this one is a PDF. So normal distribution, when it has something like that, remember x is normal mean 10, standard deviation 2. It means that that is the same as normal CD, and then lower is negative infinity, 999, and then upper is 11, yes, and the mean is 10, standard deviation 2. But for the B distribution, that probability is different. It's anti-derived from 8 to 11.
Yeah.
Make sense now? Yeah? Of the k value, 1/8 times y minus 8 dy. It's just two different distributions.
Wait, where's the 8 come from?
This one is from the lower limit. The y distribution is only from 8 to 12.
To 12?
Yeah.
But why did you have like 11? Oh, because it's to 11.
Yeah, because you're calculating probability producing widget less than 11 seconds.
Right.
So it's only tricky because of two distribution, but you can just work each of them out the same way.
Yeah.
Alright. So yeah, so if you go NCD to the left hand side, you would get, let's say distribution normal NCD, lower negative 999, and then upper is 11, 10, 2, 2, 10. Okay, so this one would be 0.6915. Okay, and then this one, again, calculator, you don't even bother solving it, just punch that in. So that would be math anti-derived from 1/8 of x minus 8. In the calculator, you need to type x, and then from 8 to 11. Okay, so the answer is 9/16, which is roughly that's exactly 0.5625. Okay, therefore, probability of producing in less than 11 seconds for x is greater than probability of producing in less than 11 seconds for y, shown. Okay, make sense?
Yeah.
Actually, as simple as that. Okay, it's not hard at all. You just need to understand it. and do enough of these questions and it will be okay. Question 3, find which machine on average is quicker in producing widgets. All right, Peter, what do you think?
Find which machine.
What are we calculating here?
I don't know, I'm thinking of like derivative.
No,
No?
on average.
On average.
Okay, I'll highlight.
Is quicker.
What does it mean by on average?
Is using the mean.
What are we calculating? Mean, yes, mean, correct. So what's the mean of machine A?
The mean of machine A is 10.
It's 10, correct. What's the mean of machine B?
12. Or wait, is it?
No. We don't know.
Yeah, wait, yeah.
How do we find it?
Z values.
No. What's the machine B distribution? Machine B is a PDF.
Yeah.
We don't know the mean. How do we calculate the mean? When I tell you that, let's see if you can figure it out.
50%.
No, that's median.
Median.
The mean.
Mean.
If I what are the think about it, just like what are the symbols for mean?
Mu.
There's another one.
EX.
Yep. Does it ring a bell now?
So is that gonna be? I don't know. What is the standard deviation for that?
For Y.
For the second one.
For the second one, well, it's even harder to calculate.
Alright.
Right? You don't need to calculate standard deviation. You need to calculate E of Y. How do we calculate E of Y?
E1. Just X times
Yeah,
EX.
that's right.
X times.
Yes. So we already have the expected value, which is the same as mean for X, which is 10, right?
Yeah.
Now we need to calculate the expected value. So on average, they're asking what is the expected value of X or Y, right? What is the expected value? And compare them.
Yeah.
Now it makes sense, right?
Yeah.
So E of Y is just the same thing. You enter the derive from the left to the right of Y times into Fy dy.
Wait, what's the EX?
Hmm?
What's the EX is equal to 10?
Yeah, because Ex is the first distribution. Remember, X is for machine A and Y is for machine B.
Alright, cool.
Okay, so the mean is 10. So Ex is just 10. Alright, and then the second one, you need to calculate that, and that's the point of this question. Okay, rather than asking find the expected value of the distribution Y, well, that's too easy. In a complex unfamiliar, they will put it into a context. In this case, the context is find which machine on average is quicker. That's the context of this question. Right? So you see, complex unfamiliar, same stuff. Right? It's the same stuff, Ex, var X, all that stuff, Ex squared. They just put into a context and you need to know what is it that you have to do. So this is what I call problem solving questions. And the only way for you to practice problem solving is to do problem solving. AKA, the best way for you guys to good at practice this is actually look at this question, work through it at home, and get stuck at some point, ask me, I give the answer, you're like, oh yeah, that's right. And then you go on, get stuck, ask me, get the answer, oh yeah, that's right, and move on. You have to practice problem solving. Right? That's the only trick, or like the only way to practice to be able to do a CU question is to do CU questions yourself at home. The only benefit, the main benefit for you guys is that you can just simply ask, if you have any question, you can ask me and you get the answer. When I was learning these questions back then, when I got stuck, I could not move on. It stayed in my mind. It's like, I don't know how to solve this one. I got stuck. I couldn't move on. And so many questions I still didn't know how to do back then. Until like way later when I got smarter and I knew more stuff, and I'm like, oh yeah, that was so easy. But like for you guys, because you guys have me, you can just ask a question. Right? But you have to make yourself uncomfortable. You have to look at a complex unfamiliar question, try it, get stuck at some point, and then ask for help. That's the only way to practice problem solving. Right? You can choose to ask for help straight away, or you can choose to leave it be, go away, come back to it, and then when you're still stuck, then ask for help. Because sometimes when you go away and then come back to the question like, oh, hang on, I can do it now. Right? Sometimes it happens. So that actually is better than asking me for answer. Yeah. But again, getting an answer is always more important than being stuck forever. Okay, so I would say the longest time you can allow yourself to be stuck on a question is 1 day, 24 hours maximum. Okay, so if you do the question at night and you're stuck, don't want to ask me yet, okay, fine, go to sleep. In the morning, you might be able to do it. If you can't, then maybe try a little bit more, and if you still can't, then yeah, go ask me. Okay, so now you gotta actually try practicing problem solving, especially for you, Peter, if you're aiming for that 14, 15 out of 15.
I'm thinking that I would get one out again.
You sure?
This one, I don't know. This one is, there's too many things.
It's too many things, but same with Unit 3. Unit 3 also too many things. It's like anti-derivative areas. Eh?
One more time today?
Yeah, one more time for Unit 3, yes. Yeah. Do you have any more exam from now to your methods exam?
I have my engineering.
So there's another exam, I guess, in the way.
I can't do anything last week, so I can't do math.
Yeah.
Last week.
And
physics, I just got to submit yesterday.
Okay, yeah, understandable. So, a bit more than a week for you. I think you might be able to do it. So later on in the second half, when when Stephen comes, I'll go through the main concept. It will refresh everything in your mind about all the main concepts, and then you go back and try. So start from simple familiar. You have the sheet for, I sent you the note for 19, right? Like the link for 19. In chapter 19, you can get to these ones here, 19D, this one. Degree of difficulty classified questions. Just do in this exact order. Simple familiar first, bam, 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 and then you're, oh yeah, confident. Finish all of this, and then get to complex familiar, right? You stress a little bit, get something wrong or something right, but you should be able to do the majority of this, and then you get to complex unfamiliar. Okay, but see if you can smash it out within the next few days though, because remember when you get to like the last week, you shouldn't focus too much on complex unfamiliar. You should do more of the simple and then SF and CF basically. Yeah, because you need to get your initial your strong concept, your main concept strong. Yeah. Okay. You can still do one or two. I'm not saying don't do anything of these nature at all. You can still do some. There are like 9 questions here. Maybe you can do 1 per day, but then the other questions is like SFCF. When you're sick of SNCF, it's just so easy. You want something challenging, then do a CU. Okay, but for the next few days, I want you to focus on getting to the CU as fast as you can, and work through these problem solving ones because you need time to work through them. Okay, so try that. All right, and by now you might have forgotten how to do some of these CU questions already. And I don't think I can go through all of this today, so you will have to. Most likely, the best I can go through is like 13, 14. I think that's it. So yeah, you can still go back and try these ones. These are very good CU questions. I try them all. I'm like, oh, that's really interesting. Right? So yeah, if you tried it and get stuck, then I can give you the answer. All right, let's finish this one here. All right, so on average, we're calculating the expected value. So once again, it's just this one here, and then you antiderive that. Y times into, the function is 1 over 8, y minus 8, I think. Yep, y minus 8. Okay, anti-deriving that, take out the common factor 1 over 8, or sorry, the numerical factor 1 over 8, and then anti-derive it. But then we need to times the y in first. So y squared minus 8y dy. Okay, so that'll be 1 over 8, anti-derive y cubed over 3 minus 4y squared from 8 to 12. Once again, when you see something like this, always factorize it. Okay, and then you get y on 3. It's much easier to work with, minus 4. Yeah. So note that I'm doing this before I actually sub the values in, so the square bracket is still there. I'll make sure you don't lose the square brackets. And then 1 over 8, sub 12 in. So it'll be 144, and then in the brackets is 12 over 3, which is 4 minus 4 is 0. You get a 0. Minus 8 squared is 64. That's it, okay. Minus of 64, and then times, in the brackets would be 8 over 3 minus 4. Oh yeah, that'll be a positive number. Okay, so that would be 64, so 1 over 8, and then times by negative 64. And then times by 8 over 3 minus 4 is 8 over 3 minus 12 over 3. Which is negative 64 over 8 is negative 8 times into negative 4 over 3. So that would be 32 over 3. So that's the expected value. So that's roughly a bit less than 11. So 10 point something. Okay, so that's roughly 10, I think 10.667 seconds. Okay, and this is the expected value of the second machine. So therefore, machine A is on average faster. Does it make sense? Because machine A, the expected value is only 10. And machine B is like 10 point something. So machine A is a little bit faster.
We can just go up a bit. Wait, what did you sub in? Oh, right. Yep. Okay. Wait, I still don't understand why. Like you sub. Oh no, sorry. Yeah, I understand that. Yep.
Okay, take your time, digest this. Ask me if you have any questions.
Yeah.
Yeah, make sense?
Yeah. Wait, Koi, like for the expected values, like sometimes I'm a little confused about like, oh, for binomials is like n times p, right?
Yeah.
But for normal distribution is like x times fx.
No, that's a PDF.
PDF.
Okay. Expected value. All right. Let me go through that a little bit. So quick notes on expected value, which is e of x. Okay. You guys all have only learned 3 main distribution. Okay. So binomial, the probability density function, continuous distribution, and then the normal distribution. Or actually, there's sampling as well. Okay. Normal.
Yeah, the sampling. Yeah.
Then the sampling distribution. Okay. Okay, the expected value for binomial e of x, right, would just be n times p. Right, because it's just the number of trials times by the probability of success per trial. Right, these ones are easier. Let's just shift them over here. Okay, and the normal is also straightforward. Okay, so I'll go through the easy ones first. The normal is just the parameter, right? It's just the parameter, the parameter mu, which is mean, right? Mu is the same as expected value of x. Right, for the normal distribution. Right, and remember, normal, it would always have the mean and the standard deviation. The mean is basically the expected value. Right, because in the normal distribution, the expected value it's actually normally distributed. It's symmetrical on both sides, so it's just the mean. This is the middle one. Okay, so that's the easiest one. Now PDF, when you have fx, right, the distribution is let's say a variable is it has an fx function for some sort of domain and then 0 otherwise, for example. Then the expected value of this one would be n to the right from the left hand side all the way to the right hand side of x times into the function fx dx. That's the first one that you really have to calculate. Okay, and then the sampling distribution, right? The sampling distribution, if you have a sample, the expected value, okay, the expected value of the sample proportion is normally just the population proportion, right? Does it make sense? Oh, whoops, what happened here? Okay, so sample proportion is roughly the same as the population. They're expected to be the same as a population proportion, right? Okay, makes sense, right? Because if you expect, let's say, the population of people in Queensland, right? if you expect about 50% to be females, and you take a sample of 100 people, what's the proportion you expect? 50%, right? To be females as well. So that's the expectation of the sampling distribution. Now, I might extend that to variance, which is var of x. Okay, so let's say the first row is for expected value e of x, right? Now for variance, var of x. Binomial var x is just your npq, or 1 minus p. Right? The binomial is straightforward. The PDF one is a little bit more involved. You need to calculate e of x squared. This is a new one.
Margin of errors belongs to the sampling, is that right?
Yes, the sampling one. Yes, margin of error is sampling. Yeah. Okay. So the variance is just ex squared minus the mean, and then you just need to calculate minus mean squared. Sorry, minus mean squared, and then e of x squared is anti-derived from left to right, but then instead of x you got x squared times into the function. Okay, so the PDF one is the one that you have to do the antiderivative. All the other ones are just conceptual, right? Our formula. So the normal distribution var x is again just a parameter, right? So the variance var of x is just the main parameter, one of the main parameters, sigma squared. That's it. Not much. Okay. Now, so for sampling, again, var of x is also sigma squared, but I'm just going to tell you what the sigma value is. So the standard deviation would be, in the sample, it would be your, think of it this way, it's your p hat 1 minus p hat over n. Remember that one?
Was it the variance of the sampling is the same to the normal distribution?
No, the normal distribution, the variance is just, remember, the normal distribution has two parameters. It already tells you, in order to have the normal distribution, you need to know the standard deviation, which is square root of variance, and the mean. So the normal distribution, like the mean and variance, you just read it off of the parameter.
Yeah, but for the sampling, the variance is like sigma squared.
Yeah, and sigma is whatever that thing is. And remember this one? This is the part of the margin of error. So, okay, I may continue this table, make other notes.
Oh, you call it for. Is that the meaning of this sigma in normal distribution is the same to the sampling?
Yeah, it's both standard deviation. The meaning is both standard deviation, yes.
Alright.
Right? The standard deviation is the idea of like most of the area will fall within from the mean, and then you plus minus 3 standard deviation, right? So that's why I may just draw this one here, and other notes. I might actually make this thing into like one of those. I might incorporate into that sheet maybe later for unit 3 and 4. I might have to update this because this table is quite comprehensive. But anyway, so for the binomial distribution, actually I'll go to the one I remember first. So in the sampling one, the margin of error, okay, so the confidence interval would always be p hat minus the margin of error and p hat plus the margin of error. Okay, where the margin of error is your z times the standard deviation, somewhat. You can think of it that way. And the standard deviation is the same thing here. So that'll be z square root of p hat 1 minus p hat over n. So normally it's p times 1 minus p over n. Okay, normally it's p, but when we do the sample, we don't know about the population. So we have to use the sample p hat value, yeah, rather than the actual population proportion, because we don't know that. So that's why it's p hat times 1 minus p hat over n. It's estimated. Okay, does it make sense? All right, so that's the margin of error. And then, okay, what else? So for the normal distribution, if you find area, then you go NCD, right? But if you find the number a number on the number line is inverse normal. It will be inverse normal. Okay, yeah, just remember those ones. For the PDF, I don't know if you guys will be able to do this, but find the cumulative distribution function. Big F of x is, the formula of that is n to the right from the left to x of ft dt. Do you remember this formula? Too long ago.
Yeah.
This CDF gives you area to the left of a certain value x. Okay? If you're comfortable with this idea, it will make some of the questions like really easy to do. You just punch a bunch of numbers in.
Yeah.
Alright. So I may go through this a little bit later. I don't know what Steven is. Let me just quickly double check. Probably on his way. Yeah, okay, that's fine. I think I'll go through some of these more important concepts later. But yeah, this table has most of the things in this one. There's one thing in the binomial one. You need to look into the idea of find sample size. So find sample size or find number of trials. So in the binomial distribution, normally you give an n and p, right? Number of trials and probability. Sometimes you get the probability, and then you find the number of trials needed so that the probability is at least a certain amount. And that's the one where you have to do, remember the table thing. You have to get like the probability is fixed, and then for each sample you calculate the probability of like getting more than a certain number of successes, and then you see which sample size or which number of trials get the probability is higher than the one that you're looking for. Does it make sense? Remember that?
Yeah.
Yeah. So that's actually in that sheet there. I have that in that sheet there. I have the calculator question for that, but I think if you need the actual question itself, let me know if you don't have the sheet, but it should be in one of the sheets I have given to you before. Okay? All right. Yeah, that's a lot of recap on all. Basically, that's all of the probability.
Can you talk more about the CDF, the big F notation thing?
Okay, yes, I can talk more about the CDF. Okay, let's use the machine. Okay, actually, let me see what the last question was. 60%. Oh yeah, that's very different. Yeah, this question is very different. The last one. All right, I'll just go through the CDF first. I'll borrow the distribution here. So let's say given x is a PDF, right, with the distribution of was it 1/8 and then x minus 8 from 8 to 12 and then 0 otherwise. Okay, this is a linear equation. I can actually sketch that. 1/8x and then minus 1. So it starts from minus 1, 0 when it's equals to 8. So that'll be from 8, 9, 10, 11, 12. Let's say from 8 to 12 here. Right, and when it's 12, 4, 1/2. So that'll be from here to here. I'll scale it out a little bit. So yeah, this is not to scale. It's just to, so it should be like a, technically it should be like a dotted line and then here. So it's not to scale, yeah? Okay, so it goes from 8 and then it goes up to 1/2. Don't ask me how I got it, just sub the values in. Okay, when you sub the values 8 you get 0, when you sub 12 and you get 1/2. Yep, okay, so this is the distribution. Now the idea is that for a unknown value x here, I want the area to the left. Okay, well, let's say an unknown value x here. I want the area to the left, and the area is given by the CDF.
CDF, yeah.
Okay, so remember we did
the antiderivative of that.
Yes, that's right. If this number is 11, then it will just be big F of 11.
Yep.
Right? So I'll show you the idea behind the CDF. So this is for CDF.
No, I think
Okay, remember this one? So normally if it's from 11, then probability of x between 8, right? X less than 11 is just n to the right from 8 to 11.
Yep.
Right? But we want it to turn it into a function because we're saying that this is big F of 11. But we want to replace the number 11 with any value of x, right? So you get a function to calculate at any value of x. And so you replace the 11 with x. So you're calculating the probability that x is from the beginning all the way to a certain value unknown x. Okay, and then when you antiderive, note that normal function is in x term, so you have to change it into a into using t. So it'll be 1 over 8 times t minus 8 dt, because later on you want to substitute x in. So if you keep the t, it's a bit hard to. Okay, so let's see how what that would be. So 1 over 8, and then antiderive, that'll be t squared over 2 minus 8t from 8 to x, right? And then you substitute the x in, so it'll be 1 over 8, and then x squared over 2 minus 8x, okay? And then minus brackets, 8 squared over 2, 4 times 8, 32, minus 8 times 8 is 64. Okay, so that'll be 1 over 8 times by x squared over 2 minus 8x, and then that'll be negative 32, so plus 32. Okay, yeah. Now this is the big F of x. Okay, so what this is saying is that this is area to the left of any value x is given by that formula there. Okay, well, and actually that helps us when we're trying to find, okay, what is the probability that that machine will produce between will produce the time less than 10, right? X less than 10, yeah, and this will be the same as big F of 10, right? Yeah, it will be the same as big F of 10, and you need to substitute 10 into the formula. So 1 over 8, 10 squared over 2 minus 8 times 10 plus 32. The reason why I'm not calculating it yet, because I want to take out common factors first, right? So let's see, 10 squared will be 100, right? If I take out 4, so that'll be 4 over 8 on the, I mean, well, write it this way, take out 4, inside here would be, actually 50, maybe I'll take out 2 only. All right, so that'll be 25 minus 4 times 10 is 40 plus 16. Yeah, and that'll be 1 over 4. And then 25, 16 is 41 minus 40 is 1. The probability is 1/4. Okay, so the area from 8 to, the area from 8 to 10, they're saying that using the big F notation, and we calculated that, that's 1 over 4. So this area would be 3 over 4. Because it's 1 in total. Okay, does it make sense?
Yeah.
Yeah. And using the big F notation, sometimes it can be quite handy to calculate areas in between. So for example, if you're trying to calculate the area from, let's say, maybe I'll write this one here. So 8, 12, and 10 is here, will be this one here. So if you want to calculate the probability between, let's say, 10 and 11, okay? This is the same as big F of 10, sorry, big F of 11 minus big F of 10. That makes sense? Why? Because big F of 11 is the area, we're talking about a triangle, right? To the left of 11, which is that one there. And then big F of 10 is the area to the left of 10, which is that one there. So when you take the big area, subtract the small area, you will get the area between 10 and 11. So 8, 9, 10, 11, 12. Right? You want the area in between here. So you take the big area to the left of 11, you minus the area to the left of 10. Make sense?
Yeah.
Well, okay, so then you just already calculated half of that. So now we just need to calculate big F of 11. And then you can actually do that separately. So big F of 11 would be sub 11 into the formula. So 1 over 8, 11 squared over 2 minus, this one is a hard one to do, 8 times 11, and then plus 32. Yeah, I think this one's got to work through it. 121 over 2 minus 88, so that will be 176 over 2 plus 64 over 2. And then everything is times 1 over 8. Okay, so that'll be 121 plus 64 is 185. 5 minus 176 is 9 over 2. Right, so that'll be 9 over 16. Okay, so that's big F11. So that would be 9 over 16 minus 1 over 4, which is 4 over 16. And the answer will be 5 over 16 is the area between 10 and 11. Okay, so note that you may think that, oh, that you still need to do a lot of calculation. But imagine if you have to do this. Right? Imagine if you have to do 1 over 8. I'll show you the alternative. X minus 8 here, dx. Okay, if you have to do this, you can take this one out, and then you're going to go x squared over 2 minus 8x from 10 to 11, and you have to do like quite a bit of this just manually, right? So that'll be that, and then inside would be 11 squared over 2 minus 88 times 11, and then minus brackets 10 squared over 2 minus 8 times 10. Yeah, it will be about the same. Regardless, it will be about the same. Okay, so when you have to calculate a lot of probabilities, sometimes it's easier to use the big F notation, right? To calculate the CDF first, cumulative distribution function. So that's the one that gives you the area to the left. Okay. All right, so just remember, area to the left.
Can you talk about like finding the sample size?
The sample size?
I think I may remember, but I don't remember like exactly.
That's from a chapter way before, and that was 15C, I think, finding sample size. Here, this one. Okay. All right, the probability of winning a prize in the game is 0.48, so we know the p-value is 0.48, but we don't know the number of games. Now they ask, what is the least number of games that must be played to ensure the probability of winning at least once is more than 0.95? Okay, so we want to, so basically when you see this question, the idea is that you don't have the p-value, but you want probability of x is at least more than equals to 1. At least 1 is more than 0.95. Okay, so so that's, and then you don't have the number of games. You actually find what is the number of games that's needed. This is a calculator technique. It's also part of the notes, I'm pretty sure, but here. Oh, whoops. What happened there? Yeah, this one. All right, try this. Try it on your calculator. This is one of those things that's like I don't do often, but hey, you just gotta know how to do this. So practice a few of these questions. Okay. All right. I'll pause. I'll finish the recording now because Steven is joining online.